Welcome to the Deep Dive.
Yeah.
We're here to break down complex topics from the sources you're interested in, giving you the key takeaways efficiently.
And today we're jumping into building construction materials. It's a fascinating area, what things are made of, their properties, and, their overall impact.
Exactly. We're working for the document Building Construction Materials, 1.pdf that you sent over. And it really covers a lot, doesn't it? From like basic clay and wood right up to modern plastics, different kinds of concrete, and it even touches on tools.
Yeah, so if you've ever wondered, what actually goes into the buildings all around us, this should be really helpful. We're aiming for a good foundational understanding.
Hopefully hitting some surprising facts, maybe, but keeping it clear, not too bogged down in technical stuff.
Right, that's the plan.
Okay, let's get started then. The source kicks off with the basics. What are building materials?
And it's pretty straightforward, definition-wise. Basically, any material that's used for construction.
Simple enough.
But what's really interesting is thinking about the history. The document points out humans started with just naturally occurring things.
Right, like clay, rocks, sand.
Exactly. Wood, twigs, leaves, whatever was available. It's kind of amazing how resourceful people were with just those basic elements.
It really is. And from that, we've developed, well, some seriously complex materials now, like plastics, which the source goes into.
Ah, yes, plastics in construction. It mentions PCC, polymer resin, and then these two broader types, thermoplastics and thermosetting plastic.
Okay, let's unpack PVC first. Polyvinyl chloride. The source says there are two main forms.
Yeah, rigid PVC, or RPVC, and then flexible PVC. The rigid kind is what you often see in construction.
Like for pipes, window frames.
Exactly. Water pipes, doors, window frames. It's durable, doesn't need much maintenance. Pretty common stuff.
And it's used outside construction too, right? I think the source mentioned bottles, cards.
Packaging, bank cards, things like that. It's quite versatile.
Okay, so what about the other types? Thermoplastics and thermosetting plastics. How do they differ?
Well, the key difference is how they react to heat. Thermoplastics, they get soft and pliable when you heat them up past a certain point.
So you can mold them.
Right. You can reshape them. And the important thing is it's reversible. They harden when they cool down, but you can melt and reshape them again.
Ah, okay. Like melting butter and letting it set again?
That's actually the analogy the source uses. It's a good one. Thermoplastics are like butter in that sense.
Gotcha. So thermosetting plastics must be different then.
Completely different. They might start as liquid or sort of malleable at low temps, but when you heat them, a chemical change happens. They harden permanently.
Permanently, so you can't remelt them.
Nope. Once they're set for good. The heat triggers an irreversible cure. So not like butter at all.
Okay, that distinction makes sense. But, with all this plastic, there are environmental concerns. The source brings this up too. Burning and disposal, specifically.
Yes, it does. And it defines plastic pollution pretty clearly, basically. Plastic building up in an area where it starts harming the environment, plants, animals, even us.
And the source is quite blanked about the dangers. It can kill plants, harm animals.
And it stresses that plastics come from toxic compounds. And crucially, they aren't biodegradable. They just stick around for a really, really long time.
Which is a huge problem. What causes this pollution, according to the source?
Well, it mentions a few things. Just, regular trash, littering, overusing plastics in the first place. Things like discarded fishing nets are a big one. And fundamentally, just not disposing of it properly, lack of good waste management.
And the effects sound pretty bad, upsetting the food chain.
Yeah, groundwater pollution, land pollution, air pollution if it's burned.
Animals dying.
And there's an economic cost, too, dealing with all that waste. It's a serious downside to consider alongside the benefits.
Definitely gives you pause.
Right.
Okay, let's shift focus a bit. What about the walls themselves? The source lists several materials. Brick, first off.
Right. And it makes an interesting point about the definition. Traditionally, brick meant fired clay.
But not anymore.
Well, yes and no. Clay bricks are still common, but the term now can mean pretty much any rectangular unit laid in mortar. The shape and method are key.
Okay. Then there are building blocks.
Yeah.
The source just says a basic unit used to build something.
Yeah, pretty foundational definition there. Can't get much simpler.
True. What about stone walls?
History lesson time. The source mentions early ones were often dry stone walls, just stacked field stones, no mortar.
Wow.
Later, especially for big stuff like city walls or castles, they started using mortar and plaster. Think medieval times. Stone's obviously very durable.
Makes sense.
Yeah.
Then concrete walls, how are those typically made?
The source describes the standard method.
Yeah.
Pour concrete into forms right there on the building site.
And then just let it harden.
Exactly. Let it cure on site. Creates a very strong wall.
And timber walls are also mentioned, but not much detail given.
Right. Just listed as an option.
Since concrete came up, the source actually digs a bit deeper there.
Mm.
It mentions stressed concrete and pre-stressed concrete.
Mm-hmm. It defines pre-stressed concrete quite clearly. It's concrete that's put under compression before it actually have to carry any weight or load.
Sort of preloading its strength.
Kind of, yeah. It helps it resist tension better later on.
Okay. And stressed concrete, is there a definition for that?
Not explicitly in this part of the document, no. It just mentions it. Generally, it involves introducing internal stresses to improve performance, but the source doesn't detail how here.
Got it. And it also mentions aggregates briefly. Refers to another slide.
Yeah, slide #5 apparently. Aggregates are the fillers in concrete, like sand, gravel, crushed stone. They provide the bulk and strength.
Okay, and holding all these bricks and blocks and stones together, that's mortar, right?
Exactly. The source calls it a workable paste. Its job is to bind the units, fill the gaps.
Make everything fit snugly.
Right, and sometimes it's used decoratively too. The key is that cement mortar hardens, creating a rigid, solid structure from all the individual pieces.
Makes sense. Okay, let's move up to the roof,
Yeah.
the protection from the elements. Roofing material is defined as just the outermost layer, yeah.
That's the basic ideal. The layer providing shelter, and there's fair few types listed.
Like aluminum sheeting. Sounds light.
Very light, yeah. About a third the weight of steel, the source says. Plus, it resists corrosion and it's easy to shape.
Where would you use that?
Truck bodies, apparently, but also building cladding and insulation.
Okay, then tiles. Traditionally clay or slate.
Yep, terracotta or slate were common, but now modern ones can be concrete or even plastic. Some clay tiles get a glaze too for waterproofing.
And plastic is mentioned again, just as plastic as a modern tile material.
Mm-hmm. Indicates it's an option now.
What about shingles?
Okay, shingles are typically flat, rectangular shapes. The key is how they're laid overlapping, starting from the bottom edge of the roof upwards.
And they can be made of lots of different things.
Oh, yeah. Wood, slate, flagstone, fiber cement, metal, plastic, and composites. Like asphalt shingles, those are super common, probably because they're affordable and last reasonably well.
Right, I see those everywhere. Lastly, for roofs, it mentions concrete. Just solid slabs.
Seems so. Solid concrete slabs used as the roof definitely sounds strong. Maybe for flat roofs.
Could be. Okay, let's come back down to the floor. Floor materials, the source groups them. Tiles, boards, stone-based, plastic-based, concrete.
Quite a few categories. And under tiles, wow, there's a big list.
Yeah, travertine. That's limestone from hot springs.
Apparently so. Then ceramic, made from heated clay and minerals. Porcelain, also clay-based, but usually denser, more water-resistant.
Faux wood tiles, too. Get the look without the hassle.
Pretty much. Then natural stone options, sleet, marble, granite, all with different looks.
And even pebbles and stones are listed, maybe for showers or accents.
Could be, yeah. More decorative, perhaps.
Beyond tiles, there's wood flooring, just timber products used for floors, basically.
Right. Either structurally or just for looks. Lots of styles, colors, species available.
And it notes bamboo is often included here, even though it's technically grass.
Yeah, it behaves similarly, looks similar in flooring format.
And then stone-based, plastic-based, concrete flooring get mentioned, but not really detailed.
Just acknowledging they exist as categories, it seems.
So that's a huge range of materials. But you can't build anything without tools. The source moves on to that, listing 10 categories.
Yeah, it gives a broad overview of what's needed on site. Tools for, let's see, brick block laying, cutting, marking.
Finishing, measuring, leveling.
Percussion impelling like hammers. Boring for holes, gripping holding tools, and excavating tools. Covers a lot of ground.
Let's look at a couple. Cutting tools, they remove material by shear.
Yeah, slicing or shearing action can be single point or multi-point cutters. There's a link for more info too.
Marking tools too, with a link. Things like knives, pencils, scribers for marking lines. Essential for accuracy.
Absolutely. Finishing tools are mentioned next, highlighting their role in the final appearance and quality. Again, a link provided.
And measuring tools, defined as tools for quantifying things like length, weight, time.
Rulers, scales are the basic examples given, and it makes a good point. Even simple measuring tools need to be good quality. Accuracy is critical in construction. You can't afford mistakes there.
No kidding. Okay, so wrapping up this deep dive, it's really striking just how many different materials go into buildings.
It really is. We've gone from, basic natural stuff like clay and stone right through to highly engineered plastics and concretes, each with its own role.
And we definitely had to keep those environmental issues in mind, especially with plastics. Their disposal, the pollution, that's a big factor moving forward.
Absolutely. It's a major challenge alongside utilizing their useful properties.
We've also seen the variety in just walls, roofs, and floors alone. So many choices depending on what's needed for a specific project.
And underpinning all of it are the tools. Can't work with any of these materials effectively without the right equipment, from laying foundations to the final polish.
So, thinking about everything we've covered, the sheer range of materials, the environmental side of things, what do you think the next big innovation in building materials might be? Where do we go from here?
That is a great question to think about. Lots of possibilities, I imagine.
Definitely something to ponder.
Well, thanks everyone for joining us on this deep dive into building construction materials.
Yeah, I hope you found it useful and got some insight into what holds up the world around us.